Hello and welcome to another video. Today I'm going to show you how to detect a loop or cycle in a linked list. So this is fairly easy to do. So here we have a linked list. I've decided just to use different colors to represent each node or piece of data. It doesn't matter what you use. It could be numbers, it could be strings, it could be any form of data. But this is our linked list. As you can see at the end, it has a loop. The orange goes into the yellow, yellow into the green, green into the cyan, and cyan back into the orange. So the issue with having a loop in your linked list is if you ever try and print it or manipulate it, you find your nodes will go around forever. So if we were, let's say, printing it, we would, let's say this is our pointer, and our pointer will keep track of where we are in the list. Let's make this a color that stands out. There we go. So we'll go to our first one and we'll print red. We'll then move along the arrow, we'll print purple. We'll then print orange, we'll print yellow, we'll print green, we'll print cyan, and then we'll keep going around printing these. And now we have an algorithm or a code that will run forever, wasting bandwidth, and it's not useful. So how can we detect loops? This is actually a fairly easy thing to do. What we require is we require 2 pointers. So there we go. We'll have a fast one and a slow one. So with the grey one, we'll say it's the fast one, and we'll say the purple one is our slow one. They both start at our first piece of data. We then move our fast one 2 spots forwards and a slow one 1 spot forwards. Now we'll check if they're on the same node. They're not, so we will move our grey one 2 spaces forwards and our purple one 1 space forwards. We'll now move our grey one 2 steps forwards and our purple one 1 space forwards. And then so on until we go 1, 2, and our purple one 1 step forwards. And now they're on the same. Node. So if we find our purple one and our grey one, so our fast pointer and our slow pointer end up on the same node, we know that there's a linked list. There's a loop in our linked list. Because if it's a linear list, let's say we will remove these 2 nodes and we'll put our pointers back at the start, so there is no loop anymore. Our grey one will move forwards 2. Our purple one will move forwards 1. Our next loop, our grey one, will try and move forwards another 2, and there is no more data to access. Why? And it still hasn't hit our purple data. So we know that there is no loop in our list, which is what we want. So now let's go and try and implement this. So here we do. Here I have a linked list already set up. So if we try to run printing this, you can see we get this loop printing out forever, which is not what we want. So let's set up our check. So we're going to do def, and then we're going to call this loop check, and we'll pass in self. You have to pass in the class that we're working with. So now we're going to say node is equal to self, and now we're going to create ourselves our 2 pointers. So we're going to do slow, and that is going to be equal to node.next. So that's, where do we go? Here we are. So that would be equal to that one, node.next, and we're going to do fast, which will be equal to node.next next. So then we'll say fast is equal to node.next.next. So now we've got our 2 pointers. The next thing we want to do is add in our while loop. So we're going to say while fast is not equal to null. And null isn't a type, so we're going to say none, sorry. There we go. So while fast is not equal to none, we are then going to say if slow is equal to fast, we are going to return false. No, we're going to return true because there is a loop. Else we are going to do fast is equal to fast.next, which is moving it 2 spots ahead, and slow is equal to slow.next, which is moving that pointer ahead by 1 again. And at the end, if we finish our while loop and fast is equal to none, we've hit the end, we are going to say return false, because there's no loop. So now we are going to print loop check. So we're going to say head.loop check. There we go. And now we will run this. Of course, we have to give that a go. So true, you can see we have got ourselves a loop. If we remove this line, so let's remove our loop, and now we run this, we get false. So that is how to detect a loop or a chain in a linked list. Thank you for watching. The code for this will be in the description, along with a link to many other Python tutorials. See you in the next one. Bye.